Welcome back to our tutorial set. In today's tutorial, we are going to look at some questions and ordinary differential equations, written in short as ODEs. ODEs. Okay, ODEs. Okay. So we have the questions on our right hand side of the screen. The first question is here it is. The order of differential equation is dash in the equation. Then they said A, highest degree, B, highest derivative, C, highest integral, D, highest power, and E, none of the above. So here, what is the answer? It is very simple. So in an ordinary differential equation, we determine the order by looking at the highest derivative. Okay, so the answer there is the number one. The answer there is P. Okay, that's all for that. And they say, what is the degree of homogeneity of f of x y equals to x y plus sine xy, like this. Sorry. Coming. Okay, so they are saying that what is the degree of homogeneity? So for the degree of homogeneity, if we can write f of x lambda y lambda as lambda power n f of x y, then we can determine the degree of homogeneity. Okay, and so here if we know what this n is, then that will be the degree of homogeneity. And so let's introduce lambda into our function. So f of lambda x lambda y will be equals to lambda x times lambda y plus sine lambda x lambda y, like this. So this becomes lambda squared xy plus sine lambda squared xy, like this. So obviously we cannot factorize these two lambdas out. Okay, so this is not even homogeneous differential equation because we can't factorize this second lambda out. We can't. This one we cannot factorize it because this is a trigonometric function. We can't factorize things outside. And so here, will we say that the degree of homogeneity is 0? No, it is not 0. So we cannot determine it. Okay. We can't determine what the degree of homogeneity is. If it was something and the answer is not inside, then we can say none of the above. But here we cannot determine it because we can't factorize the lambda square outside. And so the answer here will be what? D. Okay. Now number 3. Which of the following equations is an application of second order differential equation? Final velocity is equal to initial velocity, this. Due to acceleration due to gravity. So which of them? We have v equals to u plus at, b equals to u plus, these are Newton's equations of motions. Okay. Kinematic equations of motions or kinematic equations. And so We have W equals to Fs, D equals to F, uh, D, F is equals to Mg, and E none of the above. So which of them will be the answer? It is simple. The answer will be D, because for D we have F equals to Mg. Okay, F equals to Mg, and so we know that this G is just same as acceleration, and we know that acceleration is equals to d square s dt squared. We know that this is acceleration, and so this is a second order. Okay, this is a second order, and so it makes the whole thing become a second order differential equation. So the answer for the number 3 is D. Is D. Is D. That's all. Now let's look at the number 4. Okay, so let's look at question 5 and our solutions. So we have question 5 says, which of the following equations have a unique solution at y of 2 equal to k? Y of 2 equals to some variable k. Okay, so if you look at the equations, the first one is x minus 2 y prime prime plus 6xy prime minus 7xy equals to x, like this. And so if I put 2 inside, this particular equations, of course this one, the standard form will just be y prime prime plus 6xy prime all over x minus 2 minus 7xy all over x minus 2 goes to x over x minus 2. Now at x equals to 2, this one will be undefined, this one will be undefined, so no unique solution for this one. Now if we look at y prime prime plus y prime minus by all over 2 minus x equals to 0. Now at x equals to 2, this one will not exist, and so this one too is not part. Now we look at the third one, which is y prime prime plus 5y prime plus 6y equals to x all over 2 minus x. So at x equals to 2, this will become 0, and x divided by 0 will become undefined. You see. Now we look at the fourth one, y prime prime plus 7y prime plus 12y equals to x minus 2 all over x. Okay, right now at x equals to 2, this place will become 0. Okay, and so because of that, we can solve this one. It will become y prime prime plus 7y prime plus 12y equals to 0. So if we solve this, and this is a homogeneous higher order differential equation which we can solve, with this one we can easily solve it, so we'll get a unique solution. The answer there is now D. So 5 is D. Now 6, given that let me clean these things. Okay, so given that let me change this color. So given that y equals to e power p power x px, sorry, is a solution to y prime 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 plus 3y prime prime minus 4 y prime equals to 0. Determine the values of p. So here what do? We just differentiate this thing and substitute. So y prime is equals to p e power px. Y prime prime is equals to p squared e power px. Then y prime 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 is equals to p cube e power px, like this. So substituting, we have p cube e power px plus 3 p squared e power px minus 4 e power px, all this equals to 0. Dividing through by e power px, you get p cube plus 3p squared minus 4, all equals to 0. And now if we solve this particular question, so solving this, we'll get p1 to be equals to 1, p2 equals to -4, and then p3 equals to 0. So looking at the answers, we have 1 as 0, 1, -4. Okay, and that's C. So number 6, the answer there is C. Now we look at number 7. They are saying that the geometrical interpretation of first order differential equation is, what is it? First order differential equation. So the interpretation is that it is a tangent of some curves. Okay. So the slope, either you can say the slope or the tangent is describing the slope or tangent of some family of curves or curves. Okay. So the answer there is A. So number 7, the answer is A. Number 8, which of the following differential equation is autonomous? Autonomous means that the differential equation, the y variable does not depend on x, or in other words, it depends on itself. So looking at all this, the one that is autonomous will just be y prime equals to 2 minus y squared, because here we don't have any x. Okay, we don't have any x, so it means y depends on itself, so it is autonomous. That's just the basic explanation I can give about autonomous. Now it means 8, the answer here is C. Now 9, what is the general solution of y prime equals to 1 plus y squared? Okay, so let's see general solution of y prime equals to 1 plus y squared. So this one is just obviously dy dx equals to 1 plus y squared, like this, which is separable. You can write dy over 1 plus y squared equals to dx. And solving this, so solving this, we have tan inverse of y equals to, yes, 1. So that will be x plus c, like this. Okay. But what can we do? If this is tan inverse, then it means the y here can be equals to tan x plus c, like this. Okay. So obviously the answer there will just be the D. Okay. Because if this is tan inverse, that means if let's say you have tan x over y equals to something, maybe a, you can say that x over y is equal to tan inverse of a, like this. So it means if this is tan inverse, then we can send the tan back like this. Okay, and so the answer there will be this one, and that is the D. So 9, the answer is D. Okay, so from here we'll look at the next set of questions. Thank you for watching. Kindly subscribe.